this is a number line. Now a number line is literally just a line, and we're going to put some numbers on it. But no doubt you've used one before, and it can be a very useful tool for certain purposes. Now I've drawn my numbers line vertically, but it doesn't have to be vertical, it can be horizontal, and often in books it's shown as a horizontal line. But I prefer a vertical line because it's more useful than a horizontal one, because it makes it easier to understand that higher on the line is bigger and lower on the line is smaller. So conceptually it's more logical. Now a number line can never be complete, if you like, because a number line can go on forever in both directions. So you can only ever actually draw a piece of the number line. So that's what I've done. I've drawn a piece of the number line. Now I'm going to label the numbers on it, starting with 0, which is the middle number on the number line, because it separates the positive half of the number line from the negative half of the number line. So the positives would go on forever. I'll just number the first few of them. 1, 2, 3, and I can fit 7 onto mine. So it's a very small piece of the number line. And notice that the numbers are equally spaced, and whatever the spacing is, the same spacing must continue on the negative side of 0. So this would then be -1, -2, -3, etc. So I have the middle piece of the number line. 0 separates the positive numbers from the negative numbers. So let's look at this piece of the number line to see what is it useful for. Well, I've marked out 4 separate uses of it. Label them A, B, C, D. Now the first is for adding and subtracting numbers. Now of course you don't need a number line for that, but the concept is useful to understand. It's as simple as this. When you add a number, the result or total should be more than what you started with. Which means in order to add, you must go up the numbers line. In other words, more towards positive, so that's going up or getting a higher number. When you subtract, you do the opposite. When you subtract, you must go down the number line so that your answer will be less than it was before. So in other words, what I'm saying is that the higher you go on the number line, the bigger the number, and the lower you go on the number line, the smaller the number. So when you want to add, you must go up the line, and when you want to subtract, you must go down the line. So to illustrate that, I'll take a very simple example. Let's suppose we wish to do this addition. Example 1, let's say. We wish to do 5 minus 7, let's suppose. Well, what you would do, since the first number is 5, you find where 5 is on your number line, and it's here. Now, in order to subtract 7, my answer must be less than what I started with, which means I must go down the line. And I must go down the line 7 in order to subtract 7. So what I do is I say from 5 go down 1, 2, 3, 4, 5. Notice if I start at 5 above 0, which is where positive 5 is, I must jump 5 steps down or go down 5 steps just to get to 0. But I had to actually go down 7 steps or subtract 7. So I need to go down another 2 steps, so that would obviously take me to -2. So that's where I end up. So 5 minus 7 is minus 2. So you start at 5 and go down 7 steps. Now you don't literally have to go down one step at a time. Once you understand that starting at 5 above 0, you have to go down 5 just to get back to 0. And then, since you had to go down 7, you had to go down another 2 steps. So from 0 going down 2 steps obviously gets you to minus 2. Now, that's a simple example, but actually you can use the same principle with any subtraction or addition on a number line. Let's take another example to illustrate what I mean. Supposing we started with a negative amount, let's suppose we started this time with minus 4. And then we want to add 3, for example. Well, I'm sure you can work out what to do. The first number is minus 4. Minus 4 is below 0. So we go down 4 from 0 to minus 4. That's the starting number. We wish to add 3. Now to add, it means you go up the number line, more towards the positive, because we're adding, so you must increase. So from minus 4 to add 3, I go up 3 steps. Up 1, 2, 3, and I end up at minus 1. So minus 4 add 3 gives me minus 1. And just to remind ourselves, 5 minus 7 was minus 2. I'm going to take one more example. Let's suppose you started at minus 2 and you want to subtract 3. Well, our starting point this time is here, minus 2. And to subtract 3, it means I must end up with even less than I started with. So I've started at minus 2 and I want to subtract 3, which means go down 3, so it's even more negative. So from minus 2, if I go down 1, 2, 3, I reach minus 5. So minus 2 subtract 3 is minus 5. So it's even more negative, or if you like, even smaller. So that's the first use of a number line. It helps to keep it clear, especially if you're a bit confused about how can you add to a minus number, or how can you subtract from a negative number. The number line makes it easy. So the first use is for adding and subtracting. So to add and subtract. I'll point out again, it's not essential for this, but it's a useful concept to understand because it can save you confusion. Okay. Another use of the number line is simply for deciding which number is bigger and smaller. Now I've already explained that, so I'll just take a couple of examples and point it out. Let's label these numbers, just so that they stand out. We've already marked them all on the line. So where I had already marked the arrows, I've now put the numbers just so that they're more prominent. Now let's compare these numbers. If I were to ask you, which number is bigger out of 5 and minus 1, I'm sure you know 5 is bigger. But what if I asked you which number is bigger out of 5 and minus 5? Well, the answer is still 5, but you might be confused because they're both 5. But actually, that's a mistake. They're not both 5. One is 5 and the other is minus 5. And the one that is higher on the line is bigger. And the one that is lower on the line is smaller. So 5 is bigger than minus 5. That helps us also comparing negative numbers. So if I were to ask you, out of minus 1 and minus 2, which one is bigger? Well, I hope you'll be able to tell me that minus 1 is bigger than minus 2, because minus 1 is higher up the number line than minus 2 is. Likewise, if I ask you which is bigger out of -2 and -4, the correct answer is -2 is bigger than -4, because -2 is higher up than number 9. So it helps with deciding which number is bigger and smaller, and that can help you when it comes to ordering numbers, meaning putting numbers in order of size, which you could be asked to do. So bigger and smaller. So the concept of which number is bigger and smaller, which is useful in ordering. So a number line can help, especially when it's vertical, less so when it's horizontal. Okay, another idea that the number line can help with is with temperatures. So if I were to take this is like the scale on a thermometer. So if I simply now, instead of just numbers, if I make them into degrees centigrade, for example, might be degrees Fahrenheit, but the concept is the same, then you can get 0 degrees centigrade, and then you get warmer temperatures above, and colder temperatures, temperatures below 0, and beneath 0. So now, if we imagine that this 5 is 5 degrees centigrade, minus 1 degree centigrade, minus 5 degrees centigrade, again, we can answer simple questions about which is warmer, which is cooler, which is hotter, which is colder. And the same principle applies as did to which number is bigger and smaller. So obviously, -1 is not a warm temperature, but if you get a question which asks you which is warmer, -1 degree centigrade or -2 degrees centigrade, you should be able to answer that -1 degree centigrade is warmer than -2 degrees centigrade because it's higher. So likewise, again, -4 and -5 degrees centigrade are both cold temperatures. They're both below freezing, but -4 is warmer than -5 degrees centigrade. And obviously, out of all these temperatures, 5 degrees centigrade is the warmest, and they're actually in order on the number line. So warmer, cooler, hotter, colder. I'll put it as warmer, cooler. Is also obvious on a number line. Now, the last thing, D, the last use of a number line, is probably the most useful of them, and it is this, the concept of difference. I'm going to mark one more number just to try and make it clear for you. Let's mark the number 2. Okay, so that's one extra number. And let's use this to illustrate what we mean by difference. Well, if I were to ask you how much is the difference between 5 and 2, I hope you'll be able to tell me that the difference is 3. Now, I'm going to mark that on here. The difference is 3. And you would probably do 5 minus 2 equals 3, because you've probably learned that in order to get the difference you subtract, or difference means subtract. But that can get confusing when you have negative numbers involved in difference. So I would recommend looking at difference as something, or describing it slightly differently. It's better to describe difference as the gap, or the size of the gap between numbers. So think of it that way. It's, if you like, the separation of the numbers, or the size of the gap between them. Now, when you had two positive numbers, like 5 and 2, you can just subtract the smaller number from the bigger number, and that does tell you the difference, and you'll be right every time. But looking at the size of the gap gives you the same answer every time as well. But looking at the size of the gap actually helps you when it involves negative numbers and you're talking about difference. So now let's look at the difference between 2 and minus 1. Now, you might be able to do it by subtraction, but you might get confused when you do that. So think now for yourself before I tell you, how much is the difference between 2 and minus 1? Okay, let's see if you're right. Well, remember, difference means how big is the gap between the two numbers, i.e. how much is the separation of the two numbers? Well, on a number line, you can actually see it and you can count it, and I'm going to do exactly that. Well, 2 down to -1, the gap is again 3, because 2 is 1, 2 above 0, and -1 is 1 below 0, so the total gap is 1, 2, and another 1, 3. So the difference is again 3. Okay, let's look at the difference between -1 and -2 degrees. I hope you didn't say the difference is -1, because the gap is a gap of 1. Difference can never be negative. Difference is always positive, because a gap, either it's there or it isn't. So the least difference there can be between numbers is actually 0. It cannot be less than 0, i.e. it cannot be negative. So the difference between -1 and -2 is actually 1, because the gap, the size of the gap is 1. Their separation is just 1. So now I'm sure you'll be able to tell me correctly what is the difference between -2 and -4. Well, again, it's the size of the gap, and the gap is 2. So the difference is 2. So difference literally is the size of the gap between the numbers, or the separation of the numbers. Okay, one more. How much is the difference between 5 and -5? So in other words, that. Well, the easy way to do it is to say, well, 5 is 5 above 0, so the gap between 0 and 5 is 5. And the gap between 0 and -5 is also 5, but in the opposite direction. So the difference between 5 and -5 is 5 and another 5. So the difference between 5 and -5 is actually 10, because that is how far apart they are. Okay, so difference. So the main two things to remember about difference are, one, that a difference is always positive. It can never be negative. The least it can be is 0. And the other is that it is actually the gap between numbers, i.e. their separation, if you picture them on a number line. You don't literally have to draw a number line, but you can picture them on the number line. One final thing I'll mention about the number line is that if you did ignore the signs, then the two halves of the number line, if you imagine being able to fold the number line at 0, which is the center point, then the two halves are symmetrical. And if you were to fold it along the 0, then the two will exactly match up 1 for 1. That's a useful concept too. I'll just give one very quick example to illustrate why. It's because if you imagine where on my line is 4.7. Let's get a different color to mark it. 4.7. Well, that's not that difficult, because it's between 4 and 5. 4 and 5. Exactly halfway between 4 and 5 would be 4.5, but 4.7 is slightly more than that. But it's not as much as 4.75 or 4 3/4, so it's not exactly halfway between 4.5 and 5. It's a little bit less than that, so maybe there. So just estimate it reasonably accurately that that is 4.7. Now, if I were to ask you where is minus 4.7, that seems not to be as straightforward, but actually it is, if you remember about the symmetry. All you do is do the same thing, but if you like, reflect it down. So minus 4.7 is what we're looking for. Minus 4.7 is going to be between minus 4 and minus 5. Exactly halfway between minus 4 and minus 5 would be minus 4.5. But minus 4.7 is going to be less than that, i.e. lower down the line than that. But it's not going to be as little as minus 4.75, because minus 4.75 would be exactly halfway between minus 4.5 and minus 5. So it's going to be just a little higher than that, about there, minus 4.7. So if you look at what I just did, I showed you where 4.7 would be on the number line, and then I showed you where minus 4.7 would be on the number line. And now I hope you can see what I meant when I said that if you were to reflect the number line using 0 as the mirror line, the two halves, if you ignored the minus signs, are mirror images of each other, and that also can help you, and also especially when it comes to ordering numbers.